Hello guys, welcome back to my channel. In our previous episode, we take a look at measuring instruments. In today's episode, we are going to be looking at errors and uncertainty. How do we correct errors that is made in measurements? And what do we mean by uncertainty in measuring instruments? Before I commence to this class, please, if you are new to this channel, please subscribe to my channel and click on the like button to like my video. Thank you. Let's jump to the class. Now, as you have to know that in performing experiments, either in the laboratory or in real life, many experiments are prone to error. This error might be due to the failure in the measuring instruments. For example, if you are making use of electronic devices like your ammeter, your galvanometer, your voltmeter, each of these things can be prone to error due to the faulty instruments. If the instrument is faulty, it might yield some kind of little error. Another error that we can see is maybe variation in decimal. Maybe taking your reading, after you've taken your reading, then you start changing the decimal. Like the first reading, you get it into 2 decimal, another reading into 3 decimal, another one into 4 decimal. This might lead to what? Error in your final answer. Also, we can also see error, for example, maybe when you want to take your reading, like let's say when performing experiments with a meter rule, for instance. You are not checking the readings at a slant angle. You might be prone to error. Are we together? Now, this error that we are referring to, we are going to be looking at the 2 kinds of error. We have the random error and the systematic error. The systematic error. We have more than all these kind of error. But we're going to be looking at this based on the syllabus of jamb. The random error we're referring to are the errors that are due to like variation in readings or unpositioning of the eyes when taking reading from the meter rule or any other words instruments. Altogether, maybe if the eye is not positioned in the right manner, we can have what we call random error. Now you see this systematic error majorly are found due to faulty instruments. Now, in jamb, your knowledge will be asked on this. I think I've seen a question on that. You see, majorly for random error, we're looking at parallax error. Parallax error. Parallax error is the error due to the positioning of the eyes in a slant angle towards the right or the left of the marking. Take a look at this. Normally, this is a mark. Let me say this is a mark here. I want to take my readings on this mark. All together, I want to get the readings in this point here. I'm now positioning my eyes in this direction, in this manner like this, or my eyes is positioned along this manner like this to look at the instrument. I'm doing it in this direction or along this direction. I'm going to be having what we call parallax error. So it is the error due to slant position of the eyes. Now, to correct this parallax error, to correct it, our eyes need to be focused vertically on the marking. That is how this error can be corrected. By placing the eyes vertically on the marking. Please take note on that. In a systematic error, majorly it is 0 error. I said earlier that it can be found due to faulty instruments. The 0 error of the instrument can be corrected. It is either you return the instrument, the instrument back to its 0 position, or if for example, the instrument is at 10 mark instead of 0 mark. Then I can continue taking my reading using that 10 mark as a reference point. Then after the reading, I'll need to subtract 10 away from it. So as what? To take care of that error. That is that for error. Now, what is my uncertainty? You see, it is impossible for two people to measure the same reading and this reading will be accurate. For example, I asked two different students to measure the length of this board for me. A student might measure the length of the board to be 12.69. Another student might measure the length of the board to be 12.68. These are variations in decimal. Now, they will surely have the same initial, the whole number, but the decimals will be different. This instrument, these are what's likely what uncertainty. The measurement might be 12.65. That is what the actual measurement. All these ones are the measured lengths, not the actual. So we can't get the actual measurements by measuring with what different if two different people are taking the same measurement. Are we together? Now, every measuring instrument has their own accuracy. What is my accuracy? Accuracy is the least graduation on that measuring instrument. The least graduation on that measuring instrument are what we call accuracy. Take a look at something. Do you know that if you look at your meter rule, notice that I started with centimeter. Then I put 0. After that, we have the small value here, which is next to it. If I count 1, 2, 3, then 4. Now, this small value that is here, it is the least graduation on this rule. This small value is 0.1 centimeter. 0.1 centimeter. If we are taking the unit as in centimeter, so this small value will be 0.1 centimeter. Are we following like this? Now, as I said earlier, that all measuring instruments has their own reading accuracy. Altogether, they have the least that they can measure. Take, for example, in this my video, I'm going to be focusing on measuring instruments for length, because that is the only point where, or let me say, that is the only area where questions are often set in jamb. Now, for meter rule that I just stated earlier, the reading accuracy of a meter rule in centimeter and in millimeter will be given. For the instrument, let me take it in general. For meter rule, instruments, let's take like this, instruments. For meter rule, the reading accuracy is 0.1 in centimeter, while 1 in millimeter. For Vernier Caliper, the reading accuracy is 0.01 in centimeter, while 0.1 in millimeter. For micrometer screw gauge, its reading accuracy is 0.001 in centimeter, while 0.01 in millimeter. This is the least graduation on the instruments. If the instruments are measured in millimeter, the least gradation for meter rule is 1. For Vernier caliper, it is 0.1. For micrometer screw gauge, it is 0.001, while 0.01. We can also have that of mass. For mass, we have 0.01 in gram. Altogether, that is what reading accuracy. While for time, it is 0.001. 0.001 for timing. It is in 3 decimal. Now, majorly in jamb, The area where they do test students to convince students in JAMB is all about all this reading accuracy. Sometimes nobody will ask you what is the least graduation. Sometimes you will see it there. Why sometimes they just give you as a question? I have a question that said that which of the following readings is the correct reading of a Vernier caliper? Which of the following reading is the correct reading of a Vernier caliper? Now, note something. The question is, the following reading, which of them is the correct reading of a Vernier caliper, which is graduated in centimeter? If the Vernier caliper is graduated in centimeter, what I want you to take note is that what? Any reading on a Vernier caliper that is graduated in centimeter should have 2 decimal places. Should be in 2 decimal places. Please take a note. Take note on this. I have the following reading: 16.0, 16.35, 16.336. The only reading that is equivalent to Vernier caliper is this in centimeter. Why? It is 2 decimal. This one that is 3 decimal is the reading for a micrometer screw gauge. Why? Because we count it 1, 2, 3. Why this reading that is here is the reading for a meter rule. A meter rule should be, the reading of a meter rule should be in 1 decimal. The reading of a Vernier caliper should be in 2 decimal. In case you saw this kind of, you see this kind of question, that which of the following readings, they just give like which of the following readings here is the reading of a Vernier caliper that is graduated in centimeter. If it is graduated in millimeter, you should know that a Vernier caliper in millimeter should be 1 decimal. While the meter rule should be in whole number. You get confused. They gave you something like this. Which of the following rule is the reading of a meter rule that is graduated in millimeter? If you see something of 35.0 millimeter, it is wrong. It is 35 mm. Nothing like 35.0 millimeter. It is 35 mm. That is the reading of it because it is in whole number, to the nearest whole number. Now, for the Vernier caliper, if it is in millimeter, then it is in a single decimal. While for the micrometer screw gauge, it will not be in 2 decimal, in millimeter. Please take notes. Why is it that this one here is 2 decimal in centimeter? If you check this reading have 2. We have the main reading, which is this and this. Why this last reading here is the Vernier scale reading. The Vernier scale. The last reading here is the Vernier scale reading. Likewise, the same thing happens to this. This is the Vernier scale reading. Are we together? So these are the simple questions that they ask students. Why a lot of students fail JAMB. Thank you for watching this episode. If you find this content important, please support me by clicking on the notification button. Clicking on the subscribe button to subscribe to my channel and also like my video. Please stay with us to the end of the series. See you in my next episode. Thank you.